Okay, welcome everyone, and here we are for our 8th session of AI Summit. We have the honor today to be with Amine Remache, a software engineer at AWS, and I will let you with him.
Assalamu alaikum. I'm not sure if I should continue in English or like what's the audience's preference. And also, do we have is it interactive? Do we have the comments from people watching?
Like usually, we have questions at the end of the presentation.
Okay, yeah, it's
But
fine.
if you prefer, I can interrupt you if we have some interesting
questions.
questions.
If you can interrupt me, just do that. I usually prefer to have people to answer on the fly. Okay, so to start, I don't know if I should share the. Let me share at least something. So share my screen. All right. Okay, this is the one. Okay, I need to see myself. There is no way to see myself. Anyway, okay, so my name is Amine Remache. I'm an easy alumni. I was a graduate from 2019. I haven't prepared this part, so I was focused on the content of the presentation, but I did not prepare how to introduce myself. So basically, I went to France after my easy graduation in 2022, or no, 2020, sorry. I did the first master degree there for, it's called, I forgot the name, intelligent machines, vision and intelligent machines, VMI or something like that. Anyway. And then I did a second master degree. It's called Mobile Autonomous Systems. The second one was in Paris-Saclay. The first one was in Paris 6, Descartes, and then they merged with Diderot, and it's called now the University of Paris. So why I just try to tell my story to gain some time before the presentation. But so the reason why I had the second master's degree is that this is helpful for students that might be in the same situation, is that I wasn't sure if I should go with the PhD or find a job, because at that point in time it was COVID, the uncertainty was very high. So I was not sure. Like, it was a turning point in my life. So I went with neither PhD or a job. I had one extra year to think about what I need to do. So I did a second master degree, and anecdotally, the person who approves candidates was also an easy alumni. It's called, her name is Samia Bouchafa, just to give her a salute from here. So she accepted me, even though she told me that, like, what are you doing? Like, you already had your 5 years of engineering, you already had one master degree in France. What are you doing now? But so I thank her for the opportunity that she gave me. And then after that, during my second master's internship, I worked at a company called Munich, without H at the end. And then after my internship, they recruited me for a full-time job. And during my first year as a full-time job, I got someone reached out to me on LinkedIn from AWS. I didn't think it was a genuine thing, so I followed him, but it turned out to be a real thing. So here I am as a software engineer at AWS. This was just a short introduction, because I know that a lot of the people that are listening are students, and I know the struggle. So I feel like I'm an eternal student, so I always try to relate to students. So to start the presentation, So basically, this is just a disclaimer that the content of this presentation is not, it's not that it's not really important, but it's just used as a support. It's not what you should be focusing on, and it doesn't have all the information. I'm just going to be using this as a support for me. So the content or the most important informations would be said by me, because nowadays, like, I didn't want to have a presentation with like full informations and stuff. Like, you like, to in today's era you could easily find better in-depth knowledge than what I can give you using AI tools, or finding structured how to say, learning paths or structured courses, or stuff like that. So I'm not gonna talk here about theoretical things, but mostly about concrete or general knowledge from what I know about the topic. So basically, I prepared the storytelling. So this is my entry point. So basically, I was always an early adopter of these AI tools, and I have the chance to work in one of the major cloud providers, if not the biggest cloud provider in the world. So basically, compute is not a problem. So whenever I was using these tools internally to work on work things, we did not think, or at least we still do not think a lot about the cost of compute, because it's kind of very small compared to the cost of our infrastructure that our team or our organization manages. So basically, I got used to it quickly, and I would say that it's not that I became dependent, but at some point you get hooked. That's how every tool, or every I'm not gonna use another word. It may sound bad, but yeah. So I got used to these tools, and last year I would say that there was some kind of major breakthroughs in the models, or the foundational models that we had. I would say Opus 4 was kind of a breakthrough kind of last year. Like, the speed of how events are happening this is like is crazy. So what happened is that I was trying to start working on a new personal project. So basically what I did was use so whenever you create, I think, a new GCP account, you get 300 euros or dollars for free or of credit that you can use on GCP. So I said I'm gonna use this for using Gemini API calls on my development environment. At that time, I was using Roo code. I'm not sure if people know it. It's a fork from C-line or Klein. I don't know how you would pronounce that. It's two different pronunciations, and every person pronounces it differently. So basically, I consumed that credit in 3 days. Just as a matter of comparison, like on my day-to-day, sometimes I had like discussions that went up to 2K in just one discussion. So there was a gap between what I got used to at work and what I can have. Let me see. Yeah, and what I can have on my personal project. So at that time, what I said is that, okay, I need to find a durable solution. And for me, the natural thing was to try and purchase a VRAM or a GPU. So I bought a I would say a very good deal for an RTX 3090, which had 24 gigs of VRAM. And I tried putting Qwen 3 coder on it, but the performance was really bad, or at least from what I was expecting or from what I was getting used to. At work, I use Claude, so Claude, usually Claude Opus models. So there was kind of a real difference between what I got used to and what I wanted to have. So basically, for this model, I think I had 16K of context window, and I think at that time we already had 1 million context window models. So like it was basically unusable for me. So since then, I kind of it's not that I dropped the idea or I dropped the project, but it was parked. So I did not touch it for a lot of time up until I think it was until this March. So basically the triggering point this time was the release of TurboQuant. So TurboQuant is basically a paper published by Google. I'm not sure if it's ICLR or ICML. I'm not sure, but it will be presented this year. So it's not even presented yet. So it's still at research phase. But they claim that they can reduce the size of the KV cache up to 6 times. Okay, so what is KV cache? I'm starting to get a little bit into technical details, but I don't have supports for this, so I'm just gonna try to simplify or give you my understanding of this. So basically, the KV or key values are concepts from the attention mechanism. So I'm not sure if previous presentations presented this or not, so I'm just gonna try to re-explain them. But basically, the attention mechanism is a concept that appeared in a paper in 2017. The paper was called "Attention is All You Need." So that mechanism was kind of the inflection point of the research or the ML research field, because it introduced what we call now the transformers. And I wish I had some support for this, but so the attention architecture has, I would say, 3 concepts that we may be interested in this case. So it's the key and value and the query. So basically, you are querying. If you give it a prompt, it will try to compute some kind of a score between. So before that, you would need to have your token space. How is it called? Yeah, token embeddings. So you would need to kind of create your vocabulary, which are called embeddings, and you would have tokens that live in that space of these embeddings. So basically, your attention would try to kind of score the similarity or the attention. It's literally called the attention score. So basically, it will compute a score for each token and its relationship with all the other tokens in your prompt. And basically, you would have a lot of computations that if you did not cache them, you would have to recompute them every time. So from that, we have what we call the KV cache. So basically, every time you compute, so it's like a map of key values that would be O of 1, just not to recompute things. But as you can see, it's memory intensive. So basically, if you are not recomputing, you are saving in memory, but that memory is not something infinite. So that KV cache will eat up a lot of your memory. So basically, your context window is literally filled with your input and output tokens, and in part of it is the KV cache. So KV cache is just a mechanism on optimally saving your input and output tokens. Yeah, so in modern day, I would say systems that host these LLM models, you'd basically have the model as how to say, pre-computed weights or static weights that would not change. You would load that into your memory, either it's GPU or even your normal RAM. You can actually use your how to say, your normal RAM or your CPU to host your models, but that's actually not a very good thing as of now. It can be better in the future. So basically, you would load your weights into your VRAM. So that would take a fixed size of your VRAM, and then you would have your KV cache. So the KV cache is what will eat up your rest of VRAM. So as you can see, like, your discussion or your context window will keep growing. So it will take, like, it's not bound by the, like, your discussion is bound. That's why, for example, we have context window limits. So it's basically for not having an infinite discussion where, like, you would not have an end. So also in most modern systems, this memory is pre-allocated by the, for example, Llama CPP. So it has some kind of approximation of how much VRAM you would need. So it's also pre-computed, but that would bring us also to the precision of the values that you are saving, because at the end you have a memory, and how you are using it is that your memory is literally split into blocks, and for each block you would save a value. So that value depends on what precision you want, and that's what will get us to the term of quantization. I'm not sure if I even have it here or not. I don't think so. So I'm gonna freestyle it. Okay, so quantization, it should have been in this slide anyway. So quantization is the process of let me see how I can say this in my own words. So basically, let's imagine you have a number that's how to say, presented in an 8-bit block or whatever. So what quantization would do is it would help you kind of save space but lose precision. I'm gonna try to explain it in another way. Let's say you have 32 bits to represent the full range of the values that you can have. So it could be -2 up to 32, +2 up to 32. But if you have a limited how to say, space where you can save these values, you would need to either how to say, sacrifice the range or the steps. For example, if I want to represent values from -10 to 10 with a step of 1, that would make like 20, the size of 20, let's say, for 2 bits, not 2 bits, 3 bits, let's say for 4 bits, I can represent that. If I want to represent them with less bits, I would need to sacrifice my step. So my natural step is 1. So if I reduce the size of how many values I can represent, if I want to represent them in 2 bits instead of 4, I'm gonna do this step to be 2 or 3 or something like that. So that's basically what quantization does. It helps you, for example, the weights of the models. So when we say a model has, I don't know, 700 billion parameters, those parameters are all values. Usually the default or the default how to say floating point representation that these models are trained on is 32. I'm not sure if that information is correct or not. If not, please let me know. But in order to kind of be able to load them into your machine, you'd either have to have a very big machine that would have, I don't know, 1 terabyte of VRAM, or either try to reduce the precision of these weights so that you can be able to load your model in a smaller VRAM. So that's basically what a lot of platforms are doing today. The major one that I use is Unsloth. So it's Unsloth. So these guys usually take these big models and try to quantize them in order to be able to fit them in smaller hardware. So that's quantization. So basically, what TurboQuant paper do is they kind of quantize the KV cache into I'm not sure exactly about the details, but you'd need to go to the paper. I forgot about it, but anyway, so they have it in 3 steps. They claim to, so basically the problem that usually you have with quantization is that you would need to have to save a quantization table. So it's basically you are shrinking it, but you are also consuming your memory for some metadata. So what they claim with this paper is that they can do that without losing the performance. So basically, when you lose precision, like imagine that your weight is on, I don't know, 16 digits. If you make it into 8 digits or make all the weights into 8 digits, it might change the behavior of your model. So basically, that would take me to another concept. When you do a forward pass, so that's basically the inference. That's what we are doing. Okay, what's inference? I'm assuming that my listeners do not have context, so that's why I'm trying to re-explain the concepts. So basically, the inference is you have these static models, static weights of your model, and then your prompt would be put in the input, and you would have the response as an output. That's what we call forward pass. So that's basically what inference does, is that it doesn't have the how to say, the training loop, or like whatever you got in the output is not going to be evaluated or put back into the, or not directly put back into the input or to change the model. So we are not doing back prop. So basically that's the inference. So what took me to the inference? Yeah, so we said forward pass, and I was talking about KV cache. I lost the chain of thoughts. Can you remind me? I lost the chain of thought. Anyway, so I was talking about KV cache, about
yeah, you were talking about the fact that you stopped using the local LLM, like when, and then after you heard about this new opportunity that was released, that will be released by Google, you came back to this alternative.
Yeah. Okay. So basically, yeah. So that would bring me to the GGUF format. Basically, the GGUF format is just a quantization method or format that most of your NVIDIA cards would be able to run models on. There is also the MLX for Apple Silicon hardware. So basically, every model, for example, maybe I can show you GM4 Hugging Face. Yeah, for example, Google publishes its models in Hugging Face in like the rawest possible way that you can find. So this is the assistant. Let me go back. Yeah, anyway, I don't want to lose my chain of thought again. Anyway, so basically, some people or like open source community would take these big models and try to quantize them using these formats and publish them into Hugging Face. So basically, you would get these quantized versions and use them. That's what I do. Usually, I wait for someone to publish them, and then yeah, you can run them then on your local hardware. There is also something that came up just this week, and I was able to do it just before this meeting. Let me try to maybe show you. Yeah, so basically, so this is just a live demo of what I'm doing. So basically, I'm running a custom Llama CPP version that I built locally, and I'm using my Gemma 426B model. And then this is something new that I wanted to mention now is it's literally what I am actually trying today. It's something called multi-token prediction. So it's called MTP for short. Basically, what this does is it's a kind of research path that says that it can reduce the speed or increase the speed of your inference or the output, the tokens per second of your output drastically. So basically, there are two, I would say, schools for this. Qwen and DeepSeek and most of Chinese models, they do this MTP within the training. But for example, Gemma 4, what they did this week is that they say that they kind of use this MTP differently. So basically, they publish a new kind of assistant model that you would load with your original model. It's kind of plugging something in the head of your model that would help it do this multi-token prediction. So basically, and this is also using Turbo Quant. So we are getting the full, how to say, the full. So this is gonna load locally. So I'm loading locally. This is also happening locally. And if I do this, I don't know if you saw how fast that was, but let me see. I wanted to also show you the NVIDIA. Anyway, so that's too late for that. But so now if I do this, this is like you don't have to read what is being written, but it's just to show you how fast this is running locally. So it's even faster than whatever, like for sure, as Macron says, for whatever you're running on your machines. So that I just wanted to show you like how good it is to run something locally, no matter what they can market to you. I'm a huge defender of running things locally. What is this about? Okay, yeah, okay. So this is about Karpati. Yeah, so to summarize things or to get back people's attentions, because I know for sure that I lost most people. So what Karpati is, who is Karpati first? So Andrei Karpati was one of the founders of OpenAI. He was previously the head of AI at Tesla, and now I'm not even sure what he's doing. He's just vibe coding, or I think he said that he's not vibe coding anymore. He said something about engineering anyway. So Karpati is one of the, I would say, important people in today's AI. And he, so when I say important from the concrete or from the usefulness of AI. So he has a lot of best practices that people today are using, and he, I think, has a anyway, I can share with you the resources after, but he has a GitHub Karpati. Yeah, this one. So he has some kind of concept that he wants people to, he says that it's optimal, so it's called LLM Wiki. So he's saying that if you use this method, you're kind of getting the best of the LLM world. So I would like encourage people to watch his videos. So he has a lot of talks. He says he was the one who says the analogy about that AI is not going to replace people, but rather be augmenting people's capabilities, like Iron Man suit. So it's like the person is still the one driving, at least in the first season or the first movie. Okay. Oh yeah, so I wanted to mention something. So this is my GitHub. No, okay. I just wanted to show something that happened yesterday. So it's basically, yeah, it's this one. So this was a PR that I published, and it got merged into an open source project. And the anecdote is that it was fully vibe coded. So basically, I had an agent running. It encountered a problem. It tried to do some kind of mitigation, but I explicitly asked it to fix the root cause, and it fixed it. And then I pushed the fix and the explanation in the repo, and it got merged. So that happened yesterday. So I literally, that's the most important part of the anecdote, is that I literally did not read the code until this was merged. That's how, it's not that how much I trust it, but it's how much these models got improved. So I don't know, you can read it afterward, but so this is for the example. And then I want maybe to show another thing, which is something that I vibe coded last year. So this was also vibe coded. It was an MCP server. So to explain what MCP is Model Context Protocol. It's kind of the, so they call it the USB-C of AI. Basically, you are plugging your AI model, or you are giving it, it's like you are giving it hands or eyes or ears, or so you are giving it tools that it can use to do more. One of like the early explanations that I used to say is, at least if you come from a software engineering background, is that MCP is just an API wrapper. So basically, it's a way, or it's a protocol to help AI models understand or have a standard on how to use things. You could, like, for example, like let your AI try to build a query for a certain API, but it will not be deterministic. So determinism is very important, and it is one of the major problems of these AI tools, or like of statistics in general, because they are like Markovian models, or call them whatever you want, but they are statistical models that cannot guarantee 100% that something will happen. It will just give you a probability of something happening. So yeah, basically these MCP are augmentation of these AI models. So last year I built this MCP server. So what it does is it gives you tools that the LLM can use. This was from a concrete thing. So last year I was trying to find rent in Ireland, because I live in Ireland. And I wanted to automate that. So basically I said, okay, MCPs were hot at that time. It was something new. It was a new concept. I think it was launched in March 2025, or at least publicly. And this was like coded in May 2025, I think. So basically, I was trying to build this MCP. I also have an agent that uses this MCP. I think the repo is private. Yeah, I don't think it's public for the agent. But it actually worked. So basically, I was searching for some rent, and then I automated how to apply. And then usually when you apply, you receive an email, and that's how you know that your application went through. And that's it. Like I had an agent that did that, and I received emails saying that I applied to this and that. So it was something nice to have. So like when you have something concrete, it's, at least that's how I see. I like having concrete and pragmatic things. Okay, beyond language, what is this about? Yeah, okay, so this is about Yann Lequin's school of thought. So basically what people are aiming to have from all these LLMs, or from each iteration of these LLM, is to get closer to what they call AGI, or artificial general intelligence. Nobody knows what it is. Nobody can define what it is, but some people try. One of them was the creator of Keras library, François Chollet. It was years ago, so he wrote a paper, I think, of 24 pages about I forgot the name of the paper. François Chollet paper. Oh yeah, on the measure of intelligence. Yeah, so that paper was the foundation of the benchmark that he has. I think it's called ARC, the ARC benchmark. So at that time, he created ARC 1, which most of deep learning models were failing at. So that was his definition of intelligence. And then LLMs started becoming better. So they started kind of learning the test of the ARC. So he created ARC 2, which is now used by as a benchmark for some LLM2s. And like that's what I usually so like usually you should try to see other alternatives to what the state of the art is, or what the status quo is, and that's what he's trying to say. Anyway, so to come back to this slide, the idea that AGI is going to be reached from improving these LLMs is something that one of the godfathers of AI is against, which is who is like his name is Yann Lequin. So he's saying that basically by nature or by construction, you cannot reach AGI, but by just like throwing data into your model and having bigger and more parameters. And that's why he is one of the, I would say, duat. I couldn't find the word in English, but he is pushing for what we call world models. And to tell you the truth, I have no idea what that is. I didn't get a chance to check what that is, so I'm not gonna talk about it. And also, I think I think it's an architecture. I'm not sure about that, but it's called JEPA. So it's joint something prediction something. Anyway, let me check for JEPA. Okay, so just so I learned something on the fly. So yeah, joint embedding predictive architecture. Okay, so it's an architecture. At least I wasn't too far about that. So basically, he was the head of AI at Meta. He was the one behind the Llama models. They were open source. He was the one who was pushing for it to be open source. And recently, he got in disagreement with the Meta leadership or divergence of priorities. So he left them and opened his startup. And last week, he raised $1 billion in just as a first round. So I'm not sure how aware are you about VCs and startup fundings, but raising 1 billion in your first round, I don't want to say this, but I don't think I've seen this before. So it could be maybe the largest thing that happened. Okay, yeah. So what is next? I don't know. You're gonna have to ask this yourselves. I just wanted to mention something that I saw in the past few days, is that I saw that 2 alumni easy students have ECML papers in 2026. It's really something that I don't know. I feel proud of. I have no link to these people, but just seeing that Algerian students are contributing to top conferences in the world is really something to, like, we should start breaking this imposter syndrome that we have, and people should start aiming to publish to these conferences. ICML, CVPR, ICLR, whatever you can, or whatever you're working on, that should be your aim. And yeah, I think that's it. If I missed anything important, please let me know. If you have any questions or any, I don't know, anything, yeah, do not hesitate to reach out to me on LinkedIn. Also, I have something, it's really unrelated, but if you want to see more of me, we have a podcast, me and 2 of my friends. It's called Let Horba. Maybe some people know, even though it's now on hold. But yeah, please check out our channel, and yeah, that's it.
Thank you so much for your presentation. يعطيك صحة. It was really an honor having you with us today. Yeah, firstly, I mean, thank you déjà يعطيك صحة when you took into parameters to explain us what are transformers from the beginning and so on. يعني malgré tout, it was a really well-structured presentation. Like I was able to follow from beginning to the end. I have like a few questions. Like the first question I would like to ask is regarding the alternative that you used, which was Gwen on NVIDIA RTX. Have you tried something like, for example, a hybrid large language model? Like, I don't know if you heard about them. Like, for example, some things that combine, like I saw that IBM did something like this, like architecture that combines linear transformers with something called the state space models. Like, have you tried this kind of alternative before? Like, it's something that also reduces the KV cache in a certain measure.
No, I haven't, but I would want to take note of that. What you told me? What was it?
Like, c'est quelque chose d'assez vieux, يعني عنده كاش 2 ans. It's like hybrid LLM architecture on IBM. Something that combines state space models with.
Yeah, I'm not aware of this, but I'm gonna look.
Sorry, state space model with linear attention mechanism.
Okay.
Like like c'est quelque chose that reduces the KV cache. No, je pense pas that it's as performant as what Google outperforms, but maybe there is a way to combine both of the approaches
Yeah, so
to
now now
solve.
now it's trial and error. Everyone is trying things, whatever works, they publish it. So you can even try this yourself. It even might work and you can publish a paper. So that's
Yes,
how things work, that's research.
yes, because I've already tried it justement. This is why
Okay.
I asked you the question. Because when we go to alternative, yes, we all face this one. Like on my local machine, especially, I had to work on projects that required like privacy, and I couldn't use cloud solutions like the AWS or Azure. But I will always face this problem, this limitation. So en attendant, like for us, what do you have other alternatives than this one proposed by Gemma 4 and Google?
I was planning on trying Quen's 3.6. I'm not sure how performant that is, but it looks promising. So it's the same, I would say, class as Gemma 4. But yeah, it's still not something accessible to everyone. So I would say that you need at least 24 gigs of RAM. I don't think there is a single, or at least personal usage GPU that have more than 24. So what you can do is what people are doing now is that they are stacking Mac Minis into having them into a cluster and having bigger models there. But for that, I don't think it's, maybe it's decent, but it's not as performant as having a GPU. So silicon, like hardware, is good because the advantage is that you do not need a VRAM. People are using normal RAM to
Mhm.
load the models into them, and that's what is making these silicon like hardware good. And like the demand for them is very high, and the prices, like even Apple's official price jumped from I think 500 to 800 dollars because there is so much demand on that, and that's what like current people are using. Because if you want to use multiple GPUs, you would need to have a GPU cluster, you would need to have the hardware that goes with it, you would need to have the energy
Mhm.
supply that goes with it. So it's not as straightforward because I planned to do that. When I reached the limit on 24, I said, okay, I'm just gonna buy other GPUs and just like put them into the same machine. It doesn't work like that. So yeah.
Mhm. Thank you. The next question that we have in the chat is how can we contribute to top machine learning conferences? Because as an Algerian fellow that is really passionate about research, I hardly see myself in this kind of top conferences when I see the starting point. But when I see
Mhm.
your like votre parcours and the parcours of many easy students, that's really encouraging. So yes, I would like to thank you, and then please answer the question, which is how can we contribute to top ML
Um,
conferences?
so first, I cannot answer that because I'm not contributing to research or top ML conferences, but I can give you guidance on this. So I already published a paper during my final year. So it was about using reinforcement learning on some optimization method. So that method was created by one of the easy professors, and we tried to use reinforcement learning to improve it. So the experience of publishing a paper, I think it's not that hard, or it's not that hard as we can imagine. So you can nowadays, I don't think it's possible anymore, but usually, I mean, before you were able to publish into archive. So archive, it's called, it's
Mhm.
ARX, anyway, IV. You were able to publish a paper there, and it's like open source for research. But now I think they kind of blocked that at some point. So you would need, I don't know what are the requirements anymore to publish there, but we could start there. So it's a good starting point. Usually you need kind of I would say a mentor or someone who's already done research or is working on what you are actually interested in order to, because you can like research. The problem with the research, or it's not a problem, but the nature of research is that it is open. So basically you can go in any direction and you wouldn't know if that would lead you somewhere or not. So basically the role of the mentor is not to tell you what to do, it's to tell you what not to do. He could tell you that that path he's already tried it, or he read something about it and it would not lead to anything, so you should not focus on that, but more focus on something else. And then yeah, just be curious. Like I don't know what more can I tell you. I'm a very optimistic person, so
Me too.
it's really a mindset. So it's not something like there is no run book for it. It's a mindset of not setting up limits. I don't know if I can better summarize it, but that's how I see it.
Remache, I totally agree with you. I do have the same mindset. Like, especially like as a students, I know that you can understand us, understand what we're going through, and sometimes our studies can seem really hard, and but I do believe that the outcome is really worth the journey. So yeah, next question. Given your industry experience, what do you think about the roadmap for Algerian ecosystem to adopt large language models?
Cloud. We need local cloud. I think there is
Local.
already initiatives for that, because the idea is that when you invest in your infrastructure, it will stay. So whatever tomorrow will, like LLMs 2 years back are not LLMs today. They are literally
Yes.
more useful and more reliable. But the infra is the same. Like I'm using an RTX 3090 from 2019 or something like that, and it can load models of today. So when you invest in your infrastructure, you are building for the future and you are building for long term. So I think that's the I would say the important part for Algeria at the moment.
Okay, like especially when I do think that you're aware of all the laws that are coming on, like what is with zero set that like that prohibits using our Algerian storing our Algerian data into like servers outside our country. There are some alternatives that came out. There's like AI Grid, EcosNet recently with their GPUs as a service, but like something like I don't want like to like form personally my own opinion about that is that we are like precipitating things, that we have so many things that needs to be done before arriving to the step of the cloud, like especially like recently and here in Algeria we're not like when to build the cloud we need a certain infrastructure that will be present already, and we don't have this infrastructure and this amount of data local. So like maybe we should like
So
decompose the
it,
steps.
it's like I'm going to tell you something. So building the cloud is your carrot. Basically, the goal, your goals should not look easy. So whenever you think about a goal, if it's easy, or if it's I would say small, you're not doing yourself a favor. So basically, when you target having reliable clouds, it would force you to have these things that you're saying. But if you don't have that goal, you would always postpone doing these. So that's
Yes.
why So that's usually in project management. That's why the goals have to be big and have to have deadlines. That's also a very important thing,
Yes.
because if you don't set a deadline for yourself, you're gonna indefinitely stay in that state. So these are the two important things for defining a goal. It has to be ambitious and it has to have deadlines, and it has to have KPIs in order to measure the progress or like the success of your goal. This is very generic, very abstract. You can apply it to not only this but for everything.
For everything in your life. I understand what you mean. In fact, I have another question. Like AWS provides three kind of services: full cloud and hybrid ones, and a third alternative for local things. Like, why do Algerian companies don't turn for this alternative, like having their own servers of AWS installed in their own data centers?
I'm not sure. So that's up to them. Like it's not.
Okay.
So basically,
De ton opinion,
it's usually.
selon votre opinion.
Why they don't have them? I don't know. Like
Hmm.
for example, I kept asking because I work in an internal organization about infrastructure and specifically network monitoring. So I have like I see the network of the whole AWS infra. So whenever we had all hands, so all hands is like the top leaders, they come do some talks and they open question, like they open the mic for people to ask questions. So whenever I ask, is they give you the I would say the diplomatic answer, saying that at the moment we need, like, for example, they would say that they need two internet providers at least, independent internet providers, and they need two independent energy providers at least. And they say that most of African countries um, do not meet this requirement. And
Okay.
that's because I was asking them. I didn't want to ask specifically why are you not in Algeria, but why are you
Okay.
not in Africa? The only
In
region in
Africa.
Africa is in South Africa, so at least for AWS. Um,
Okay.
they have what we call point of presence, which is
Mhm.
smaller data centers, but they are not regions. So in AWS, you cannot choose AF something. There is only
Algeria.
AF
Okay.
South one. Yeah.
Okay.
But these are what like leadership is telling me, and I'm just telling you what they tell me.
Okay. Thank you so much. I think that we have no more questions. So one, so once again, I would like to thank you for your presence, and it was a pleasure having you with us for this hour. And Yatik Saha, and I hope that it will not be the last time we will have the honor to having you with us here.
Allah.
And thank you.
Thank you.
Ah,